So the first 3 questions are asking you to evaluate. And remember that the word evaluate means find the value. So basically all you're doing is substituting. If there's one thing that I want you to make sure that you get from this is that you remember that when you go to substitute, you rewrite the problem with parentheses instead of the letters, so that when you go to substitute negatives, you don't lose the sign, as you often so much do. That's the biggest mistake that we make. So what I mean by that is if you're looking at number 1, you would write it as 4 times W plus, open the parentheses, and then inside of the parentheses you have V minus 5 and then times T. Then you go in and you put in the values. So for example, W is equal to 2 and this is a W. V is equal to 8 and this is 8. T is equal to 4 and this part's 4. Now order of operations, please do not rely on your calculator to do them for you, because the order of operations you have to do. You have to know what order to do. So order of operations, you do 4 times 2, that's 8. You go in the parentheses and you get 3. And 3 times 4 is 12, and 8 plus 12 is 20. Order of operations, we go inside first. 6 times 1 is 6. And then I have 6 divided by 36. So this is going to be a little confusing, because a division problem is also a fraction. So this is 6 times 6 divided by 36. 6 divided by 36 is actually 1/6. So I can simplify that. And then 6 times 1/6 is actually just 1. That way. So the other way that might be a little less confusing would have been if you would have done, okay, number 3. Number 3 is, again, it's an order of operations. It's not an equation, it's an expression. They tell me that x is negative 20. So I would rewrite the whole problem. 28 minus 13 plus the absolute value of negative 4 plus, and I say negative 20. Well, negative 4 plus negative 20 is negative 24. The absolute value of negative 24 is just 24. And then you do 28 minus 13, because this gets rewritten, plus 24. 28 minus 13 is 15. And then 15 plus 24 is 39. Okay, number 4 is asking me to simplify. And when I simplify, I just simply combine like terms. Remember, you can only combine w squareds with w squareds, z squareds with z squareds. And the only time that your exponents change is if you're multiplying variables or dividing or power to power.
11w squared plus 7z.
Nice. 4 and 7, 11w squared plus 7z squared. Excellent. All right, number 5, another simplifying, but now we need to do what first?
The parentheses.
Distribute, yes. So we can rewrite the 3x because it is going to remain as it is, plus, and then you're going to do 4 times 5x, and that's going to give you 20x. And then you're going to do 4 times positive 2, and that's going to give you positive 8. And now we could simplify. 3x and 20x is 23x plus 8, and that's the final answer.
Wait, can you FOIL this or no?
Number 6, determine if x equals 6 is the solution of 3x minus 8 equals 16. 2 ways to do this. Step 1 is to actually solve that equation for x to see if it's equal to 6. But the other one is so much easier to just plug in 6. You want to know if putting 6 in here makes it true. 3 times 6 minus 8. We want to know, is it equal to 16? Well, 18 minus 8 is 10. It is not equal to 16, so no, it is not a solution. write and solve an algebraic equation. So I know I'm going to have an equal sign. 2/9 times a number, 2/9 times a number, minus 12 is 18. There's my equation. And then you solve it. Dotted line down the bottom. And then you undo that minus 12, add 12 to both sides. Don't freak out about the fractions yet. You get 2/9 x is equal to 30. At this point, so because I am currently multiplying x by 2/9, I am going to divide by 2/9. But when you divide by 2/9, it's the same thing as multiplying by the reciprocal. So you multiply by the reciprocal of both sides. That's going to give you x alone equals, now remember, you're allowed to cross divide before you multiply. That means you're allowed to say, oh, 2 goes into itself once and into 30 15 times. And 15 times 9, 10 times 9 is 90, plus 45 is 135.
Like granddad.
Okay. So dotted line, add 12 to both sides, and I get 7 is equal to v. Check your solution. Well, -5 is equal to v, which happens to be 7, minus 12, and 7 minus 12 is -5, which is equal to -5, so I know it's correct.
Oh my god, yes.
Divide by -8 on both sides. X is equal to positive 7. Next
I
guy.
didn't do numbers.
Solve and check. So again, I am going to divide by -7/9, which is the same thing as multiplying by -9/7. And that's going to give you y is equal to, if you put it over 1, 6 times 9 is 54, positive over 7. You could leave it like that. You do not need to change it into a decimal. That's absolutely fine to leave it like that. Number 11 was one of those things that I hope that you understand what it means. You are going to be giving the formula, and you're going to need to identify that that's the one you use. Arithmetic sequence is, if you recall, it's a sequence of numbers that have a common difference. And so you're doing the same thing to the next ones, and it all depends on who the first number is. So for example, in this case, if I wanted to know the 21st term, I need to figure out first what I'm doing to every prior number. That's what we call the common difference. I am subtracting 15 consistently. That is my common difference. That's what we call D, the common difference. If you think about logically, what this is saying is, if you started with 230 and you're going to subtract 15 all the way till you get to the 21st term, it means that you subtracted 15 20 times. Because if you think about it, this is term 1, term 2, 3, and 4, and look at how many times I subtracted 15, only 3. So you subtract 15 21 minus 1 times, 20 times from. Because of the fact that we are subtracting 15 20 times from the original first term, the mathematicians gave us a formula which says when you have an arithmetic series, to find the nth term, in this case the 21st term, you are going to take the first term and you're going to add whatever n, so in this case it would be 21, minus 1 times the common difference is. So you could either logically discover that if you're subtracting 15 20 times and then get that value and add it to the first number, which is 230, that would work out. Or you could use the formula. And the formula is assuming that we are going to find the 21st term. So we want to find what the 21st term is. My first term is 230. That's what A1 is. And I am multiplying 21 minus 1, so 20, times the common difference of -15. And then it's just a quick little punch in the calculator. This is really 20. 20 times negative 15 is negative 300. And we're going to add that to 230. And we're going to get that the 21st term in this specific series is going to be negative 70. And it makes sense that you're subtracting 15 20 times. That means you're going to subtract 300 from the original first term, which is 230. So this is the formula you would use. A1 means your first term. N is how many terms you want. And D is the common difference. But if you did not memorize this formula, which you'll be given it in the exam, you could still figure it out by using your common sense of understanding that if I'm subtracting 15 to get to the 21st term, I'm subtracting 15 20 times. That's 20 times negative 15, which is negative 300. And that amount is being subtracted from the original very first term, 230. Number 12 is asking me to identify if it is an arithmetic sequence. And to figure out if it's arithmetic, I need to know if there's a common difference. Am I doing something common to each thing?
Yeah.
Well, let's see. I went minus 4, minus 4, minus 4. So the next three terms are going to be, if I minus 4, negative 4. If I minus another 4, negative 8. And if I minus another 4, negative 12.
Two cases.
So absolute value, if you guys remember, absolute value is actually an operation. It's an operation, and the operation is telling you the distance from 0. It's asking for the distance from 0. So when I am solving for an absolute value equation, I have to remember that what I need to do first is isolate the absolute value, which it is, because right now it's just 2x plus 4. It's the whole absolute value. And then I know that the inside can be equal to a positive or a negative, so that when I take the absolute value, it gives me positive 2. So literally all you do is, once you have your absolute value by itself, 2x plus 4, you set it equal to 2, and you set it equal to negative 2, and then you solve. Regular. Minus 4, 2x equals negative 2, divide by 2. My first answer is that x is negative 1. Then I do the same thing on the other side. Minus 4, 2x is equal to negative 6, divide by 2, and I get that x is negative 3. So I have two answers. X could be equal to negative 1, and if you look at it, negative 1 times 2 is negative 2. Negative 2 plus 4 is 2. The absolute value of 2 is 2. And the other solution is negative 3, because 2 times negative 3 is negative 6, plus 4 is negative 2, and the absolute value of negative 2 is 2. Number 14 is asking me to solve the proportion. Going back in our heads about proportions, we know that it means their cross products are equal. So 9 multiplied by x is 9x. I know that has to be set equal to 12 times 15,
180.
which is 180. Now I just do my regular one-step equation. Divide by 9.
20.
X is 20.
That was like, I learned that.
So nice.
So, all right.
Oh, is this the and or thing?
This is a regular equation. There's no inequalities. Remember that. The and or is referring to the inequalities, because if it's greater, if it's less than. So this one is just a regular equation. There's an equal sign. Distribute, combine, rewrite, and solve. First of all, I'm going to rewrite this 17 plus distribute 3x minus 6, and then minus 11x is equal to negative 7x minus 14, and then rewrite that plus 14. Simplify each side independently. I can combine the 17 and the negative 6. 17 minus 6 is 11. And the 3x and the negative 11x is minus 8x. equals, these cancel each other out, and I'm left with just negative 7x on that side.
Oh, so then it equals that?
So then I need to solve for x. Who's on the wrong side?
The 11.
The negative 8x, right? You want to bring him over to the other side with the other x guy. So you get 11 equals 1x. And remember, 1x is just the same thing as x. So that means x equals 11. Then we'll just skip that one. Okay.
I hate this one.
Oh, yes. So we're transforming these. Remember, you're going to make believe that the number or the letter you're solving for, in this case r, is the only variable. You're going to think to yourself, what would I do if we were isolating for r? We're going to make believe that r is the only variable, and you're going to treat everything else like a number and think to yourself, what would I do in order to get it by itself? Well, order of operations says that if you knew what r was, you would be dividing by n and then adding s. So just like if this was a number and you're trying to get r by itself, the first thing you're going to do is minus s from both sides. That's going to leave you r divided by n is equal to 4v minus, I'm going to make a cursive s because my s's look like 5s.
Yeah, let's see that.
And then to get r alone, I need to undo that division. So I am going to, very well, multiply by n to both sides. Remember, you're multiplying the entire expression by n. That leaves you r equals n times 4v minus s, and that's all you do. Boom, you're done. Alrighty. Number 17. Number 17 is asking me similarly to solve now for b. So I am going to try to get b by itself. First, you're going to get rid of the divided by 4, and you're going to multiply by 4 to both sides. That leaves 4a minus 3b equal to 8 times 4 is 32c. Again, I'm solving for b. So that means I need to get rid of the 4a. 4a is currently positive, so I'm going to minus 4a from both sides. That's going to leave me with negative 3b is equal to 32c minus 4a. What do I do now?
You add by
You divide by negative 3, right? B is being multiplied by negative 3, so to undo it, I divide the entire expression by negative 3. So my final answer is just B is equal to 32C minus 4A all over negative 3. That's it. So it's, again, you're treating these literal equations as if they were regular algebraic equations. The only difference is that instead of being able to add numbers when you bring things over, you're just going to get another expression. All right, moving on into the unit of linear functions. Hopefully by now, because of all of the functions that we've done in all the graphing, you remember that an x-intercept is the value of x when y is 0. So I just simply go, oh, I want to know what x is equal to when y is equal to 0. And then, really, I just get 3x is equal to 7, divide by 3, and I get that x is 7/3. That's all I need to do.
You don't do as decimal?
You leave it as an improper fraction. In algebra, from this point forward, you always leave things, unless they ask you for a decimal, you always leave it as an improper fraction, unless you can simplify. Next guy. 19. Oh, so much fun we used to have, and we started this in pre-algebra. So, when I am asked to find the slope, I remember that the slope of a line is the change of y over change of x which is y2 minus y1 over x2 minus x1. So that's what comes to mind when I see the word slope. If it helps you to write x1, y1, x2, y2, you're welcome to do that. Remember that when you're doing your subtraction of y's, if you did y1 minus y2, your denominator best be x1 minus x2. The order doesn't matter. However, you have to be consistent. If you subtracted 7 minus negative 2, then you need to start with negative 6 for the bottom. But let's just keep it in the order of the formula. y2 is negative 2. So please, this is the part that I worry about for you guys. I worry that you're going to lose the negatives and the sign rules. So when you write these things out, don't just write them quickly. Be mindful as you're writing them. I'm doing y2, which is negative 2. So negative 2 minus 7, which is y1, over x2, which is negative 6, minus, and then I say negative 6. This is going to create this bottom to be a positive. Now in this case, this calculates to negative 9 over 0, and we must remember that if 0 is in the denominator, what is it called? Undefined. Undefined. So 0 in the denominator, undefined. Think of it as like if you had to stand on top of 0, it would fall and nobody would find you. Undefined. As opposed to 0 in the numerator. 0 in the numerator means the slope is 0. This means that this is a vertical line, and if the 0 was in the numerator, it would mean it would be a horizontal line because the slope is 0. So let's try this one. You guys, all right. x1, y1, x2, y2. So it's y2, which is negative 2, minus y1, which is 1, over x2, which is 3, minus x1, which is negative 2. It's 3 minus negative 2, which becomes 3 plus 2. Negative 2 minus 1 is negative 3, and 3 plus 2 is 5, and we leave it as a fraction because slope is always a fraction where the numerator is the rise and the denominator is the run. Looking at this, I hope that you remember that when you look at the equation or the function that they're giving you, because there's an x and a y and the biggest exponent is 1, I know it's linear. It's a linear function. It's going to draw a straight line. There's a couple of ways to do this. Way number 1 is to think about the idea of, well, what happens if I was to make it in standard form, ax plus by equals c. Then I could actually find the x-intercept by plugging 0 in for y, and the y-intercept by plugging 0 in for x. Or the other way is to transform it into y equals mx plus b. When I want to do that, it means I'm going to add 3 to both sides. I get x plus 4y is equal to 3. I'm trying to get y equals mx plus b, so I'm going to minus x to both sides. And I get 4y is equal to negative x plus 3. Divide everything by 4. And remember that the coefficient in front of x is really 1. So now I have y equals negative 1/4 x plus 3/4. That means that if I wanted to graph this, I would have to begin at 3/4 and go up 1 and down 1 to the right 4. That would take probably a lot longer than if I would have recognized that in standard form, you could just plot the intercepts. If I wrote this in standard form, I would have x plus 4y is equal to 3, because I would add 3. Then I could find the x-intercept by plugging 0 in for y, so it would be x plus 4 times 0, which is 0, equals 3. That means that at 3, I cross the x-axis, and I could do the same thing with the original equation in standard form and try to find the y-intercept. when I plug 0 in for x, I get 0 plus 4y equals 3. Yes, I'm going to have a fraction. Y is equal to 3/4. That just simply means that 3/4 is between 0 and 1 on the y-axis. So if this is 0 and this is 1, 3/4 is going to be right there. Now I have 2 points, and I simply just connect the dots. (22) asks me to graph, and I know that this is in slope-intercept form, which is y equals mx plus b. When it is in y equals mx plus b, it's really easy to just extrapolate the b, which is -1. That means you go to -1 on the y-intercept on the y-axis. And the slope of the line is 2/3. That means you're going up 2 to the right 3 from your y-intercept. So it would mean you'd go up 2 to the right 3, and then you put your dot, your point, right here. Connect the dots, and there's your line. Number 23 is asking us to write a linear equation in slope-intercept form for a line based on the fact that an internet company charges $4.95 per month plus $2.50 for each hour. So if we think about how much it's going to cost, we know that the total cost is going to be the flat $4.95 every month plus $2.50 per hour. Okay. Number 24 is asking you to write an equation in slope-intercept form. So we know that slope-intercept form is y equals mx plus b. We can hopefully distinguish that this is the y-axis and this is the x-axis. And if I wanted to identify the y-intercept, what is the y-intercept? It's like right here, correct? So if I'm counting by ones, -1, -2 would be the y-intercept. And I can then look for another point, maybe this one here.
It's kind of hard to see.
It is difficult to see, and that's why you have to just kind of look through as much as you can.
And it's not,
I know that I'm going downhill from left to right.
Coach Taylor, some of them are.
So I am going down 2 to the right 3, so the slope is -2/3, but please remember that you need to have x and y. So it's a linear equation because there's a y equals mx plus b format. Great. 25. Hopefully you guys find this one pretty easy. The y-intercept is 2. That means that I'm going to go to 2 on the y-intercept. And I'm going to go down 1 to the right 2. So I go down 1 to the right 2, put a point, and I can keep on doing that and put another one if I wanted to make 3 points. But all you really need to make a straight line is 2 points. 26 is asking you for an equation in standard form. Here we go, where we have to actually put forth a lot of the mathematics. So if we have to put the equation in standard form,
Are you recording?
so an equation in standard form is ax plus by is equal to c. You have 2 points. What can I definitely do with 2 points?
Graph.
What am I definitely able to calculate when I have 2 points? The slope, yes. The slope of that line. If I find the slope, I will then have point slopes, which means I can use the point slope formula. So the slope formula is -1, so y2, -1, minus y1 over x2, which is 6, minus x1, which is 5. That gives me a slope of -5/1. Now I have the slope and I have points, so I can just pick one of the 2 points. Let's pick the one that has positives, just because it's easier to work with. So then I would say my point is 5, 4, and the slope is equal to -5. The point slope formula is y minus y1 equals m times x minus x1. So all I have to do is substitute y1, which is 4, and slope, which is -5, and x1, which is 5. I have a point slope formula. They want it in standard form, so what do I do now? Exactly. You distribute to rearrange it. So distribute, rewrite, y minus 4 equals -5x plus 25. To put it in standard form, I want the ax on the left, and I want a positive. So I'm going to have to add 5x. That's going to give me 5x plus y minus 4 is equal to 25. Now I'm going to add 4 to get that over to the right, and I have ax plus by equals c. That's my standard form. Number 27, point slope. Again, we would recognize that point slope is y minus y1 equals m times x minus x1. They tell me the slope is 4/3, so I can immediately replace the m with 4/3. And I have a point x1, 3, and y1 is 0. So I can replace y1 with 0, and I can replace x1 with 3. That is the equation in point slope. Right there. That's all you needed to do. You don't need to distribute. You don't need to do anything else, because in order for it to be properly written in point slope, you have to have the format of y minus y1 is m times x minus x1, so that you could identify x1, y1, and m. So this is probably one of the easiest ones to do, because you don't have to do anything after putting in the point and putting in the slope. Write the slope-intercept form of the equation. So the slope-intercept form, y equals mx plus b. That means I need to distribute. I get y minus 3 is equal to -2/3 x, and then I'm going to multiply -2/3 times 6. If you have your calculator, it's going to immediately tell you the answer is -4. Still not in slope-intercept. I have to add 3 to bring it over to the right, and I get y equals -2/3 x minus 1. That is slope-intercept.
That was pretty easy though.
Same thing with 29. 29, put it in slope-intercept, so distribute again. Rewrite y minus 1 equals 3/4 x minus 9/4. I have to add 1 to both sides. Y is equal to 3/4 x. Well, 9/4, -9/4, is really -2 1/4. So -2 1/4 plus 1 means that you're going to be at -1 1/4.
But we keep it a mixed number?
It would be -1 1/4. If you decided to leave it as an improper fraction, it would be -5/4. The only reason that I went ahead and made it 1 1/4 is because since it's the y-intercept, it makes it easier to graph if you know it's 1 1/4. Okay, 30. Write the slope-intercept form of the equation of the line that is parallel to. So remember, as soon as you see the word parallel, what comes to mind? When you see the word parallel, hopefully in your head, you see two lines that never cross, and that means that their slope is the same. So parallel lines have equal slope. Perpendicular have opposite reciprocal. Remember that. So if we're working with the parallel ones, they want an equation in y equals mx plus b. They want the equation in y equals mx plus b that is parallel to this line and goes through this point. So the only thing I need from him is his slope. Because if I know what the slope of that line is, then I know what the slope of the new parallel line is. And if you remember to transform that into y equals mx plus b, I would subtract 9x You get 3y equals negative 9x plus 6. Divide everything by 3. I get y equals negative 3x plus 2, but the only part of that line I need is the slope, because it means that my new line, the slope is also negative 3. And now that I have a point and my slope, I put it into point slope. And the point slope is going to be using that point. So y minus y1 equals the m of negative 3 times x minus x1. That's point slope formula. They want it in slope intercept, so I just simplify with the order of operations. I add 3 to both sides, and now I have y equals negative 3x plus 18. Notice that this equation and this one are different in that they have different y-intercepts because they are different lines. But they're similar because they both have the same exact slope because of the fact that they are parallel. In a similar way, when we're working with perpendicular lines, we do the same exact process. We find the slope of the line we're perpendicular to. We remember that the new line is opposite and reciprocal. And then we use this point. So to get the slope of this, what do I have to do first? Put it in slope-intercept form. So I'm going to minus 4x, and I get negative y equals negative 4x plus 12.
Divide by negative 1.
Very nice. Divide everything by negative 1, because I don't want negative y equals, I want y equals. Y equals positive 4x minus 12. The slope of the line I am perpendicular to is 4. What is the slope of the new line? Negative. What's the reciprocal of 4 over 1?
Wait, what do you divide it?
1 over 4. All that work was just to get the slope of my new line. But now I have the point and I have the slope. So point and slope. Using the point slope formula, y minus y1 is equal to m times x minus x1. Distribute, because they want it in slope intercept. So I get y minus 2 is equal to negative 1/4 x. Remember that when you multiply by a fourth, a third, a half, a fifth, you're dividing basically by that denominator. So a fourth of 8 is 2, because 8 divided by 4 is 2, and because it's 2 negatives, it becomes a positive. But I still don't have it in slope-intercept form. In order to do that, I have to add 2 to both sides. So it's y equals negative 1/4 x plus 4. And notice again, negative 1/4, the opposite of negative is positive, and the reciprocal of 1/4 is 4. So we are perpendicular. When I'm solving a linear inequality or an inequality, I have to remember in this case it's the couple of rules. Solve it like a regular equation, so I'm going to add 7 to both sides, and I get y is less than or equal to 12. To put it in step builder notation, you do the squiggly. Y such that y is less than or equal to 12. We then draw on our number line values that are going to show that we get to 12. So 4, 8, and 12. Less than or equal to means you have a closed circle and shaded to the left. So remember, a greater than symbol or a less than symbol have open circles. If they have extra ink underneath, they have extra ink inside, and they're closed circles. Okay, 33. Undo of that division through multiplication. H is less than 27. The value of h such that h is less than 27 is the set builder notation. Okay, I'm counting by, if that's 0, I guess I'll count by 9. Double 18 times 3 is 27. Less than, open circle, because it's not or equal to, and shaded to the left, because it's less than.
Do we have to put it in the set?
Okay, next one. Here's Z. I am solving for Z. And in order to do that, I undo what's being done to Z. Z is being divided by 5, so I'm going to multiply by 5 to both sides.
Oh, I did the reciprocal.
That's when you're dividing by 5, you multiply by 5. 5.
I know, I did.
Okay.
So that's going to leave Z on this side. The symbol doesn't change. And 5 times negative 2/3 is negative 10/3. This is the same thing as Z is less than negative 10/3, which is 3 1/3. And the reason I want to know that is so that I can graph it. So if I go to graph it now, I am going to go to negative 3 1/3. So if this is negative 1 and this is negative 2 and this is negative 3, negative 3 1/3 is somewhere more than negative 3. So that's negative 2, that's negative 1, that's negative 3. So it's like here. It's an open circle. And I am going to be Z is less than, so I'm going in that direction. Set builder is the value of Z such that Z is less than negative 10/3.
On the test, I'm definitely.
Okay, with this one, again, remember it's an inequality, so don't forget that. You treat it like a regular equation where you distribute first. You get negative 3W. Okay, so that would be negative 18. Less than 4W plus 16 plus 1, where we can combine 16 and 1 and make it just 17 right away. And then you can probably, a lot of you guys see that if I added 3W, I would keep W positive. But some of you might get a little afraid of doing that because it might kind of make it so that you forget to do the flipping. So you might want to bring it over that way. So I would add 3W just to keep the W's positive. Rewrite the 17. This becomes 7W, negative 18. Then you can subtract 17 on both sides. And you get negative 35 is less than 7W, which is the same thing. If I wanted to flip it right away, I could actually write it as 7W is greater than negative 35. Think of it this way if you forget. It's pointing to the 35, so you make sure that it points to the 35 as well. So if here it's pointing to the 35, you want to keep it pointing to the 35. Then you divide everything by 7 and you get W is greater than negative 5. So that when I go to put it in my set builder, W such that W is greater than negative 5. I can count by 2's, I guess, negative 2, negative 4. And negative 6. Negative 5 is somewhere between 4 and 5 and 6. Open circle because it's not or equal to, and greater than shades to the right. Okay, compound inequality. Basically, same exact thing. The only difference is that you're doing it twice on the same equation. So to isolate x, I'm going to add 1 to everything. That leaves negative 2 is less than or equal to 2x, which is less than or equal to 6. Divide everything by 2. I get negative 1 is less than or equal to x, which is less than or equal to 3. This means that it's an and, it's an in-between. X is literally between negative 1 and 3. And because they're both equal to, they're both solid, and you shade in between.
Wait, can you go back upside?
With step builder notation.
Yes, thank you. Set builder is literally just squiggly x such that, and then you just rewrite everything the same.
Oh.
And that's always the case. With set builder notation, it's always going to be squiggly, x or y, whatever variable, big line, and then the thing. Okay, this is an OR, and we know it's an OR because it says OR. So we know that ORs go out that way. So that kind of keeps us in check to make sure we're doing it correctly. So if we're solving this inequality, we're going to add 3 to both sides. And we get r is greater than 7, so that's the first half. And then we go to the next one, minus 1 minus 1. R is less than negative 2. So we have the fact that r is greater than 7 or r is less than negative 2. So 7, let's say I count by 2s, 2, 4, 6, 8, 7 would be here. Open circle, greater than goes outwards. And then the other one is negative 2, so if I'm counting by 2s, open circle, less than goes this way. So if in the process of doing this, you notice that your graph doesn't go outwards and it started as an OR, you must have done something incorrect. Because if it is an OR, it goes outward. And the set builder notation would be squiggly r such that r is greater than, you should always start with the smaller one. So, and if you don't, it's okay. R is less than negative 2 or r is greater than 7.
You have to write or?
You do have to write or because if you do not, then you're saying it's an and.
Good.
Yeah. All right, absolute value inequalities. So with this point here, or I'm sorry, with this inequality here, remember that it's absolute value, which means that you could have on the inside, it could be a positive or a negative because when you take the absolute value, it becomes a positive. Please remember that your original one, you've got to be greater than the positive, okay? So from here, it's an or because it's greater. It's a greater than symbol. So you set up the 2. Z plus 4 is greater than or equal to 7. Or, what's the other one?
Z minus 4.
No, Z plus 4
is less than or equal to negative 7.
Yes. You only change the negative and positive, okay?
And the sign.
Mm-hmm.
Good job.
Yes. And let me move it. Okay, and then you just solve each one independently, right? Minus 4, you get Z is greater than or equal to 3. Or,
So you just flip the sign and change it. Okay.
and then this one would be Z is less than or equal to negative 11. So this number line that I provided for you guys is kind of difficult. So let's count by, I guess, 3s. Negative 3, negative 6, negative 9, negative 12. So negative 11 would be right between negative 9 and negative 12, and it's a closed circle, and less than shades to the left. And then the 3 would be, we counted by 3s, a closed circle, and shaded to the right. And remember that because it's an OR, because it's greater, our set builder would be the value of Z such that Z is greater than or equal to 3 or Z is less than or equal to negative 11. So this guy is a less than, which means it's an and. So when I set up my 2, remember, always check to make sure that it is originally within the absolute value is less than or greater than a positive. So then from there, we set up our 2 cases. Case 1, x plus 4 is less than 2. This is an and because it's less than. Case 2, x plus 4 is greater than negative 2. Solve each independently. X is less than negative 2. And x is greater than negative 6. Because it's an and, you have to know how to write it properly together like a compound inequality that it is. And to do this, remember that and means that you're right in the middle. You're right in between. So we know that x is between -6 and -2, because -6 is the smallest one. And so it's going to be always pointing to the less thans. And then when I go to graph it, so x such that I am dealing with negatives, so I am going to write on top of that 0 and just make 0 this. So it'll be -2, -4, -6, -8, and so on. So then, or you could have even counted by ones, which probably would have been a little bit better. -1, -2, -3, -4, -5, and -6. I have open circles at -6 and at -2, and I'm shaded in between. All right, done with absolute value equations and inequalities. So, big rule with absolute value. Remember, please, that you need to make sure that when you are setting up absolute value, you remember that when you set it up equal to the positive and to the negative. And then you solve each separately. Okay, substitution and elimination. All right. The word substitution means to plug in for another. They're telling me that y is equal to 2x. So literally what I'm going to do is take that 2x and put it in this guy's y, because that's what substitution means. That means that my two-variable equation of 2x plus y equals 8 is now 2x plus 2x equals 8. 4x is 8. I know that x is equal to 2. If x is 2 and y is 2 times x, then y must be 2 times 2, which is 4. So I always answer in terms of a point, because what we're really trying to find is the point of interception between those two. When x is 2, y is 4. Substitution. Again, in order for me to substitute this one, which is not as easy as the other one, I need to put it in y equals form, right? I want to have either y equals something or x equals something so that then I could plug it in. Which of those two is the easiest to do that for?
Y.
This one here. If I rewrote this,
Minus.
what would you guys do?
Add y,
Yeah, I would too, to make it positive, right?
and then I was just
And then minus 3? Yeah. So you could get y equals 2x minus 3.
I did it a different way.
Then what we do is we actually plug in that 2x minus 3 into this guy's y. Remember, we solved for this one, so we're going to plug it into the other one. And then you distribute, exactly. So it's 5x plus 7 times y, which is 2x minus 3, equals 17. Distribute the 7. You get 14x minus 21. Rewrite. Equals 17. Combine like terms, remember? 4x plus 5x. 14x plus 5x is 19x. Minus 21 equals 17.
I struggled with this so bad, and now I get it.
Add 21. I'm so glad that you guys get it now. 19x is equal to 1 plus 2 is 38.
So you divide that by 2.
Yep, divided by 2, and I get that x, I'm sorry, divided by 19 and get x is 2. Yeah, divided by 19. X is equal to 2, and then what do I do?
You plug it in.
Yeah, plug it back in to find out what y is equal to. So if x is 2 and 2x minus y equals 3, and you can plug it into either one of the two, it doesn't really matter. So I'm going to plug it in here. 2 times 2 is 4. 4 minus what is 3? 1. Right? You could do it the long way. Negative y is equal to negative 1, so y equals positive 1. So when x is 2, y is 1. When you're asked to solve, system of equations, remember that what you're really being asked to do is to find that point of intersection. And because of the fact that we're looking for that point of intersection, we're going to get an answer that's x comma y. There's three different ways to solve the system. The first way would be to graph the two linear functions. And the second is to use elimination. And the third would be to use substitution. The elimination method is going to try to eliminate one of the two variables, x or y. Looking at this one here, the easiest one to eliminate, and it's already set up to do so, is the y. Because when you add down, you would get 4x, it would cancel out the y's, equals 20. Then we just solve like normal, divide by 4, and we get that x is equal to 5. That means my point is 5 comma something. In order to get that y value, I take that x value and plug it into one of the two equations. It doesn't matter which one, you're going to get the same answer either way, if you did it correctly, obviously. So let's plug it into the top one. 2 times x plus 3y equals 19. 10 plus 3y is equal to 19. Subtract 10 on both sides. You get 3y is equal to 9. Divide by 3. Y is equal to 3. So my point is 5 comma 3. With this one, it's a little different than the one right before because in order to eliminate a variable, I'm going to have to multiply one of the two equations, or both equations, by some value so that I could get canceling numbers. Looking at this, the easiest variable to eliminate would be the y because I have a positive and a negative already. I can multiply this bottom equation by 2. That would give me 8x minus 4y equals 8. And then if I rewrite the top one, you will notice that now you have the possibility of eliminating the y's. We can add down, and we get 14x. Our y's cancel out, which is good, equals 28. Divide by 14. We get that x is equal to 2. So 2 comma something. Now we plug that 2 into one of the two equations. Let's plug it in the top one. 6x plus 4y equals 20. 12 plus 4y is equal to 20. I can subtract 12 on both sides. And I get 4y is equal to 8. Divide by 4. And I get that y is also equal to 2. So my point is 2 comma 2. All right, number 44. With this one, I can go ahead and add straight down because I notice that the y's are opposite signs and the same, so they're going to cancel. So 2x plus 3x is 5x. 5x is going to equal 6 minus 11 is negative 5. Divide by 5, and I get x is equal to negative 1. If x is equal to negative 1, I could plug it into the top one to get what y is equal to. And that gives me negative 2 plus 2y equals 6. Add 2 to both sides. I get 2y is equal to 8. Divide by 2, and I get y is equal to 4. So my solution is x negative 1, y 4. Okay. Number 45. With this one, we notice that nothing is currently set up to eliminate quickly. So I would have to multiply negative 1. You could do it to either the top or the bottom. That's up to you. If you multiply the top by negative 1, then you're going to get negative 7x minus 3y is equal to negative 1. Remember that you multiply that to the entire equation, not just to the 3y. And you rewrite the 9x plus 3y equals negative 3, and now you can just simply add straight down. And when you add down, you get 2x equals negative 4. Yeah. Divide by 2, and you get x is equal to negative 2. So if I plug it into the original, 7 times x plus 3y equals 1. And again, you could have multiplied -1 to the bottom and then plugged it into that value into whatever one of the two originals. So it still works out that way. -14 plus 3y is equal to 1. Add 14, and I get 3y is equal to 15, where if I divide by 3, I get y is equal to 5. So x, comma, y would be the answer.
I do.
Okay, now we're into the multiplying. In these cases, remember, when you're multiplying variables, you add their exponents, but multiply the coefficients. So this is simply 3 times -2, which is -6. A squared times A means I have 3 of them. B5 times B3 means I have 8 of them.
Next one, I'm confused.
47, lots of little movement that I have to do. There's a power to power, it's adding, it's doing all sorts of stuff. So the first thing you do is scope it out and see what you're doing. Hopefully you notice that here and here you're going to have to do a power to power. The first term, 4a4b8, I just merely rewrite because there's nothing to do. Plus, for the next term, I have to do exponents first. So this is a to the 4, power to power multiply, b to the 8, times 2. So that one is really 2a4b8. Right? For the last term, you have the 4. And again, when you're raising a power to a power, as you're doing here, power to power, you multiply those. So you get A4, B8. Now when we step back and look at all of our 3 terms, we notice that they're all like terms. They're all A4, B8s. So 4A4B8 plus 2A to the 4B to the 8 plus 4A to the 4B to the 8 is 10A to the 4B to the 8. 48. Remember, it's a fraction, it's a division problem. Break it up little by little. If you have to be visual and write it out, do so. 2 over 16, if I looked just at this part here, I could say that that's really the same thing as just 1/8. Now, if I have 3 x's on top and I have 1 on the bottom, every one that's on the bottom that has 1 on the top divides away. If you need to see this, imagine this. You have 3 on top, 1 on the bottom. One of them divides away, you're left with 2 on top. If I have 5 on top and 7 on the bottom, if I have 5 on top of these y's and 7 on the bottom, these 5 y's are going to divide away 5 of these, leaving 2 on the bottom. Again, if you had to visualize it, you could say you have 5 y's on top and 1, 2, 3, 4, 5, 6, 7 on the bottom. Anything divided by itself is 1. So you would simply just go, this divided by itself is 1, this divided by itself is 1, and this, as well as this and this. You realize you're left with 2 on the bottom. If I have 1 z on top and 3 on the bottom, good. This guy's going to knock one of them out, leaving 2 on the bottom. And that's my final answer. Alrighty. Number 49. Find the sum or difference. Well, in this case, it's a difference because there's a minus sign. But I got to be careful because when I subtract an entire parentheses, you've got to distribute that negative to everyone. So in reality, you've got 7m squared plus 3m minus 4 minus 3m squared minus 9m plus 5. Now we just combine like terms. 7m squared minus 3m squared is 4m squared. Positive 3m minus 9m is minus 6m. And negative 4 plus 5 is positive 1. That's my final answer.
Do we have to put it in?
Alrighty. With this one, because you are adding, you're not changing the sign of anybody in front that you're in front of. So you're either able to just say, okay, I'm just going to forget about that plus and just combine like terms. 4y squared and 4y squared is 8y squared. 3y minus 7y is negative 4y. And negative 7 minus 2 is negative 9. This is not an adding and subtracting. This is a foiling. It's a binomial times a binomial. So I need to distribute or FOIL, however you want to see this. First times first is 9. R squared times R squared is R4. That's my first times first. The outer terms would be negative 15 R squared T squared. That's the outer. The inner terms would give you positive 15 R squared T squared.
Would it be T squared R squared?
It could be T squared or T squared R squared or R squared T squared, but remember standard form is alphabetical order. That way you recognize that the middle terms are going to cancel out. And then the last term is positive 5t times negative 5t is negative 25t4. Now, you notice that the two middle terms are going to cancel out, and you're left with just 9r to the 4 minus 25t to the 4. This was a special case that if you recognize from the beginning that they are conjugates, one is a positive and one is a negative of the same thing, you would know that the outer and inner cancel out, so you don't have to do outer and inner. You just do F and L. First times first, last times last, and you're still going to get the right answer.
This is the.
Okay. Number 52 is also a multiplication, but because it's not really a binomial times a binomial, you just simply distribute each of the first to everybody and each of the second to everyone. So 2n times 3n squared, 2 times 3 is 6, n to the third. 2n times negative 4n is negative 8, n squared. 2n times 1 is positive 2n. But I'm not done yet because now I have to move to the 3. Positive 3 times 3n squared is positive 9n squared. Positive 3 times negative 4 is negative 12n. Positive 3 times 1 is positive 3. And now I combine like terms. 6n cubed is the only cubed guy, so he just gets rewritten. Negative 8n squared plus 9n squared is positive 1n squared, of which I don't have to write the 1, but I can if I'd like to. Positive 2n minus 12n is negative 10n, and then we have that plus 3 floating along. Okay, moving right along.
Oh yeah, is this that one's? Not
This is FOIL. It is a 5y plus 6 squared. So that means I'm multiplying it by itself twice. You could either remember the shortcut, a plus b squared is a squared plus 2ab plus b squared, or you can actually write it out and FOIL it out. 5 times 5 is 25, y is y squared. That's my first. My outer terms give me positive 30y. My inner terms also give me positive 30y. And my last terms, 6 times 6 is positive 36. Combine the middle term, the o's, you get 25y squared plus 60y plus 36. Remembering we only add exponents when multiplying. So 30y and 30y is just 60y. This one is also a special case, once more. Difference of perfect squares means you're going to cancel out your o's, your outers and inners. So you could just go straight to first times first, which is 4k squared, and last times last, which is negative 25r squared. Now, if you didn't recognize, because in the middle of the test you were nervous, you didn't recognize that this was a difference of perfect squares. If you did first times first, outer times outer, inner, inner, last, last, your middle term would cancel out anyways, and you would still get this answer. 2c minus 1 squared is simply 2c minus 1 times 2c minus 1. These are same sign, so you're going to get a middle term. First times first, outer times outer, minus 2c, inner, inner, also minus 2c, last, last, positive 1. Together, our middle term combines to negative 4c. You rewrite the 4c squared and the plus 1, and that's your final answer. GCFs. The greatest number that 9 and 6 are both divisible by is 3. If I have x squared and x is the largest that I can take out of both of them, and both of them have a y cubed. Okay. This one, 5, 6, and 7 has nothing in common. None of them have all A, because only the first two have A. And none of them have a B or a C. So, 1 is the only GCF.
What if it was some?
Factor. In order to factor, remember the steps that we go through. First step is it GCF?
Yes.
Yes. What can I factor out of 10 and 22? 2. X, I have 2. Y, I have 1. Z, I have 1. What is left? Please remember that when you're asked to factor, they don't want only the GCF. They want to know what's left over. So here we have, if it helps you guys to write your GCF underneath each part, then 10 divided by 2 is 5. X2s are away, Y's are away, Z's are gone. And then minus 11 X, Y. All right. With this one, there are 4 terms. And when there are 4 terms, the way of factoring is by grouping, right? So there's no GCF right now that I could take out of everybody. So step 2 would be to group factor. So I have 4 terms, so I'm going to group these 2 and group these 2. Then you GCF. What can I factor out of 2xy and 4? 2x. Remember, you only take out the negative if the leading one is negative, right? So if 2 had been negative, you would have factored out negative 2. So you're left with y minus 2. What can I factor out of these guys? 3. Well, there's a plus there, so 3, and you're left with y minus 2. That makes it easy. You got your y minus 2, which is your twins, and the 2x plus 3, which is the other parentheses. And that is your final answer.
Just did this.
Hopefully you guys look at this and go, oh yeah, this is unfoiling, and it's an easy one because A is 1. So it's going to be parentheses, parentheses. Remember that when the coefficient is 1, you just get 2 parentheses immediately. And so you say to yourself, what multiplies to negative 28 and adds to 12?
14 minus 2.
And it's 14 and 2. So you would get M and M, and you would get 14 and 2, where the 2 is negative so that it adds to a positive 12. Now, I want to show you, for those of you guys that are like, oh, I'd rather do the whole, like, ACB. So if you recognize that this is the shortcut, you can do that. However, if you don't, then what multiplies to A, which is 1, times negative 28, which is negative 28, and adds to positive 12, you would have then discovered it was positive 14 and negative 2. Then you could use those to expand out the middle term. M squared plus 14m minus 2m, and then minus 28. And then from here you group and group Take out the m, you're left with m plus 14.
Nope.
Take out negative 2, and you're left with m plus 14. So then your twins are m plus 14, and the other one is m minus 2.
Oh no, it's just.
Alrighty.
I don't get this one.
I wasn't thinking of that.
Okay, again, this one is a quick one where I could say, oh yay, a is 1. That means that I just have to look at negative 56 and negative 1. So I could say x minus 8 and x plus 7 and go straight into that. Or you could do the ACB. What multiplies to 1 times negative 56 that adds to negative 1, I would discover it's also negative 8 and positive 7. That would expand out the middle term, minus 8x plus 7x minus 56. Then I could do my grouping, factor out the x of this one, factor out positive 7, and I would get x minus 8 and, because here's my x minus 8s, and x plus 7. Either way, I get the right answer. Awesome. Okay. This one definitely requires that I use ACB because it's got the coefficient of A is equal to a bigger number than just 1. So, what multiplies to negative 60 and adds to positive 17? 12 and 5 multiply to 60 and add to 17. Both. But if I did a positive and a negative, that would give me negative 7. And then if I did the other one,
That's not it.
Wait,
that's not it. Yeah. That gives me a negative 7, not 17. That's a positive. So it's actually 20 and 3, where the 3 is negative and the 20 is positive. That multiplies to negative 60 and adds to positive 17. That expands out, so 5t squared plus 20t minus 3t minus 12. Then I group factor, take out 5t from the first parentheses, you're left with t plus 4. Hopefully we're going to get t plus 4 in the other parentheses. Take out negative 3, and you're left with t plus 4, so I know I did it correctly. T plus 4 is 1, and 5t minus 3 is the other one. All right. Number 63. Product of AC, sum of B, but remember to always GCF it first. Step 1, GCF. I could factor out a 2 first. If you didn't GCF it first, you're going to have to at the end, as you will see. So I take out the 2, and I'm left with 3p squared minus 10p plus 8. Now I do ACB. Is it a special case? No. GCF. Then I do ACB. So I am doing the ACB method just for the inside, for the parentheses. So what multiplies to positive 24 and adds to negative 10? 6 and 4, negative and negative. The negative 6p, negative 4p expand out the middle term. You still have the 2 out there, so don't forget him. I'm just going to draw an arrow to remind me that it's still there. When I do group factor for this part, I could take out a 3p and I'm left with p minus 2. I could take out a negative 4 and I'm left with a p minus 2. So for this part, I get p minus 2, 3p minus 4, but remember you still have that 2 out there. Factor. Step 1, GCF. There is none. Step 2, is it a special case? Yeah, it is. It's the difference of perfect squares.
What?
Difference means subtraction, and these are perfect squares. That's what a special case is. The square root of 49a squared is 7a. The square root of 169 is 13, and because I have no outer and inner, it means that it must have been 7a plus 13 and 7a minus 13. All right. So, next guy. All right. Step 1. GCF. I could factor out a 3 and an x3. And I'm left with x squared minus
Guys, can you stop?
25. From that, you hopefully recognize that this is the difference of perfect squares. So this is x plus 5 and x minus 5. But don't forget that 3x3 is still there. That's your final answer. Okay. Next guy. Okay, so step 1. Is there a GCF out of this? No, there's not. Step 2, is it a special case? Okay, so in order to check to see if it's a special case, remember, you want to take the square root of 81. That's 9. Take the square root of 16. That's 4. And then you multiply those. 9 times 4 is 36. And double it, and it gives you 72. So it is a special case. Okay, so 9 times 4 is 36 times 2 is 72. So yes, this is a special case. And the special case is really 9c plus 4 times 9c plus 4, which is just 9c plus 4 squared.
Do we have to wait?
This guy, same thing. Look at those big numbers. Oh my goodness, if only there was a way to make sure or to see if this could be shortened up. Is there a GCF? No. Is it a special case? Well, the square root of 25, x squared is 5x. The square root of 49 is 7. And because this is negative, if you think about it, this would be negative 35 plus negative 35
Is positive 70.
is negative 70. Oh, so let's do that again.
Wait, 5 times 7?
This here would give you 35, negative 35x.
Negative 35 squared is positive.
Now that's, if it looks like it's the, let's do this. If we did this, look at what would happen. You would get 25x squared. You would get negative 35x, and negative 35x is negative 70, not positive. And negative 7 times negative 7 is positive 49. So, no, this is not factorable. This is not factorable. Let's look at it again. If you look...
Can't you do positive?
Nope. If you look at it again, the square root of 49 is 7, but there's a negative here, correct? So that means that when you do 5 times 7, 35, and double it, you get 70. If you were to write down what you got, you would get 5x minus 7 and 5x minus 7. But when you multiply the negative 7 and the negative 7, it doesn't give you negative 49. These have to be opposite signs in order for this to give you a negative. And if they were opposite signs, then they would cancel out the middle term. So this entire question is what we call not factorable. He's already prime, basically.
Can I start now?
Yeah. This is asking me to solve. And remember that when you're solving a quadratic such as this, you're asking it really, you're trying to find the place where it intercepts the x-axis, where what x is equal to when y is 0. It's already set up because it already has factored and it's already set equal to 0. So simply all we do is you set each parentheses equal to 0 and then you solve. So when I go to solve this one, it's pretty straightforward. I just get x is negative 5. That's one answer. And the second answer, I'm going to get 4x equals 3. Divide by 4. X is 3/4. So the two answers are negative 5 and 3/4. Or 0.75, yeah.
I thought you don't put it this.
You could leave it as a fraction always,
So
yeah.
you say x equals negative 5 and 3/4?
Yeah, x equals negative 5 and x equals negative 3/4, yeah.
When did we do this? 'Cause
Okay, for this one, in order to solve this, I have to factor first. So I go into my head about factoring. Oh, how do I factor? Put it in standard form. Is there a GCF? Yeah, there is. 4b. You're left with 3b minus 2 and then equals 0. Now you set each part equal to 0 because 4b could equal 0, which means that if 4b is equal to 0, then b is 0 is one answer. And then the other one is 3b minus 2 equals 0. And when I do that, I add 2 to both sides, and I get 3b is equal to 2, divide by 3, and you get b is equal to 2/3. So I get that b must equal 0 and 2/3. This would mean that if I was going to draw a graph, my parabola would cross the x-axis at 0 and at 2/3. All right. Number 70, solve by factoring. Oh no, it has to be set equal to 0. So I'm going to minus 45 before I do anything else. When I do that, I get y squared plus 4y minus 45 is equal to 0. Then I'm supposed to factor. So I could either do the ACB method, or recognizing that a is 1 and that there's a shortcut, I could simply ask myself, well, this must be y and y. And what multiplies to 45 and adds to 4? 9 and 5, where positive 9 and negative 5. And again, if you did the product of AC sum of B, expanded the middle term, grouped, and factor, it would have taken a little longer, but you would have still gotten to this step here. Now we set each parentheses equal to 0. So y is equal to negative 9. And if y minus 5 is equal to 0, I add 5, I get y is equal to 5. So my two solutions are that y must equal negative 9 and 5. And remember, you can always check your work by plugging these independently back in to see if it works. Excellent. All right. Same type of concept. Put it in standard form. Subtract 3. 9n squared plus 6n minus 3 equals 0. To factor, step 1 is the GCF. What can I factor out of all of this? 3. And you're left with 3n squared plus 2n minus 1 equals 0. Now I have to factor this out by, it's a quadratic trinomial, so I'm going to do product of AC sum of B. What multiplies to negative 3 and adds to positive 2? Yeah. What multiplies to negative 3 and adds to 2 is negative 3, positive 3 and negative 1. Because together, 3 plus negative 1 is 2, and 3 times negative 1 is negative 3. So we expand out, rewrite that 3, 3n squared plus 3n minus 1n minus 1, group, I could take out 3n, and I'm left with n plus 1. Take out negative 1, and I'm left with n plus 1. Whew, I got twins. N plus 1 is the twin, 3n minus 1 is the other guy, and that 3 is out in front. But I'm not done yet because I'm not asked just to factor. I'm asked to solve. Bless you. So that means I have to factor and then set each parentheses equal to 0. 3n minus 1 is equal to 0. Add 1 to both sides. 3n is equal to 1. Divide by 3. N is 1/3. And then when I set up the n plus 1 equal to 0, and I minus 1, I get n is equal to negative 1. So n is equal to 1/3 and negative 1. That extra 3 that I had out here was just used to factor. I don't need to set him equal to 0 because he's 3. There's no variable. Only the parts that have variables need to be set equal to 0. And then from there, I get my answers.
Can we take a break?
Solve by factoring. There's no GCF, so I'm going to immediately go into ACB. What multiplies to negative 20 and adds to negative 8? 10 and 2, negative and a positive. So I'm going to expand that guy out. So it's 4 4b squared minus 10b plus 2b minus 5 equals 0. Group my front 2, group my back 2. If I group the front 2, I take out 2b, and I am left with 2b minus 5. You got to factor something out. So what can I factor out of the next one? Just positive 1. And you're left with 2b minus 5.
Wait, but I thought it was. Wait, how
So
is it
then
negative?
you've got the twins of 2b minus 5.
I thought it was negative
And then the other guy is b plus 1
2.
equals 0. Then I set each parentheses equal to 0. So I got 2b plus 1 equals 0, minus 1. 2b is equal to negative 1, divide by 2. So my first one is b is negative 1/2. And then the other guy is going to be similar. 2b minus 5 equals 0. Add 5 and I get 2b equals 5. Divide by 2 and I get b equals 5/2. You could write negative 1/2 and 5/2. You could write negative 1/2 and 2.5. 5 over 2 is really 2.5. So whichever one you want with that.
I just made the. I made.
All right. Solve using square roots. They tell you how to solve. Well, to use square roots, it means you have to have an equation that you could then take the square root. So let's add 1 to both sides. 64x squared is equal to 1. Divide by 64. X squared is equal to 1 over 64, which means that to unsquare, I'm going to take the square root, remembering that when you take the square root, you get two solutions, the positive and negative. So that means that the square root of x squared is just x, and the square root of 1 over 64 is the square root of 1 over the square root of 64, which is 1 over 8, but it's positive and negative 1/8. 74. Solve using the quadratic formula. Well, I remember the quadratic formula is x equals opposite b plus or minus the square root b squared minus 4ac divided by 2a. Yay! So we have a is 1, b is negative 14, and c is 22. So x is going to equal the opposite of negative 14 plus or minus the square root of b, which is negative 14 squared, minus 4 times a, which is 1, and c, which is 22, all divided by 2 times 1. When I punch these things into my calculator, carefully, remembering how to do this, this first one becomes positive 14 plus or minus the square root of, well, negative 14 times negative 14 is 196. Negative 4 times 1 is negative 4. And negative 4 times 22 is negative 88 over 2. Well, this part here, I can then say 196 minus 88. So it is 14 plus or minus the square root of 196 minus 88 is 108 divided by 2. Notice how it says round to the nearest hundredth. It means I'm going to get a decimal. So then I take the square root of 108 and I get 10.4 or 10.39 because that's the hundredth. So this becomes 14 plus or minus, well, the square root of 108 is 10.39. Now I have two different problems to do. I do 14 plus 10.39, so 14 plus 10.39 is 24.39, divided by 2, and I get 12.195, or just 12.2. And then I have to do the same thing, but instead of the plussing, I am going to minus. So now I am going to do 14 minus 10.39, and 14 minus 10.39 is 3.61, divided by 2, and I get 1.805, which is 1.81. So my two answers are x is equal to 12.2 and 1.81. All right. Don't overdo your work. Look at number 75. They only want to know how many solutions using the discriminant. They don't want you to actually solve. The discriminant is the guy on the inside of the square root, because we know that if the inside of the square root is negative, you're going to get no solution. If the inside of the square root is positive, you're going to get two solutions, the positive and the negative. And if the inside of the square root is 0, well, the square root of 0 is just 0, which is only one solution. The discriminant is b squared minus 4ac. b is negative 6, so negative 6 squared minus 4 times a, which is 3, and c, which is 3, gives you 36, negative 12 times 3 is negative 36. That is 0, and 0 means one solution. Don't be confused like I used to and think that 0 is the 0 solutions. It's one solution because the square root of 0 is just one answer, 0.
Wait, what was the formula?
All right, same thing with number 76. b squared minus 4ac. Well, b is negative 3. Negative 3 squared minus 4 times a times c. Negative 3 squared is 9. Negative 4 times 1 is negative 4 times negative 8 is positive 32. That's going to give me a positive number. So I'm going to write two solutions. That's all I need to do. I don't need to find the solutions. Just say how many there are. Same thing for number 77. Please remember to put it in standard form before you do anything. That means we're going to have to add 2 so that you get 7x squared plus 6x plus 2 is equal to 0. And then b squared minus 4ac. b is 6, so 6 squared minus 4 times a, which is 7, and c, which is positive 2. 36, 28 times 2 is 56. 36 minus 56 is going to give you a negative number, so no solutions.
Wait, it's a negative number. It's
These guys here, you are not going to be tested on. So we are actually not going to go over 78 or 79 or 80
Yay.
Is this right?
or 81, 82, 83, 84, or 85. So the last question we have,
Wait, are those right?
now this is the last question we're going to go over. They want us to find the axis of symmetry, vertex, y-intercept, and whether we open up or down. Well, step 1 is always to put it in standard form, which means I'm going to have to subtract 4x and then put it in standard form. X squared minus 4x plus 5 is equal to 0. I can immediately look at A, and because it's positive, I know this opens up. Now, the next thing I need to do is look through and find the axis of symmetry. The axis of symmetry is x equals, remember your axis of symmetry must be written as an equation. X equals opposite of b, which happens to be negative 4, so opposite of b over 2 times a, which is 1. That's going to give me positive 4 over 2, which is positive 2, so the axis of symmetry is x equals 2. Please don't forget the x equals. The next thing, the vertex. The vertex is the xy where the x is 2, because I'm located on the axis of symmetry. So if I have x squared minus 4x plus 5, and I want to know what is y equal to, I literally plug in to this x. I am going to plug in my 2 from the axis of symmetry. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. Plus 5 is 1. So when x is 2, y is 1. That's my vertex. The y-intercept, if you recall, when it's in standard form, it's this guy here. It's C. But it must be a point. So the y-intercept is actually 0, comma, c, which is 5.